Hi, I'm Ben Bradley. We'll be going over the new version of the UNIQ control system today, going through page by page on the different functionality. So I guess we'll just get started and start on the home screen here. Now this is the page where you're going to do just manual operation of your machine. So you have jog, forward, and jog reverse functionality. So this is if you're just loading up your machine and getting material to the shear. We also have micro forward and micro reverse. This functionality is a short burst of material movement where it comes into handy is when you're setting up your shear dies and taking the material through the shear dies, make sure you have everything lined up and don't crash. The other functionality we have here is your shear control. We have a cycle button. Now that is going to be a full cycle. Shear will go all the way down and come all the way back up. We also have shear up functionality, where if the shear was down for some reason, we can just hit that button and bring it up. And then on the opposite side of that, we also have down function. So we could hit down and just slowly bring that shear down. And these up and down controls really help when you're setting up your shear dies to make sure we're cutting a panel correctly. The other readouts we have on here is the top, we have what's called current position. So if you were running a panel out, say you had 2 feet of material sticking out of your machine, this readout would be 2 feet. So this is giving you an idea of what is outside of your machine. Across the top is a status. So as the machine is functioning, it's going to tell you what it's doing. So if we're driving material forward, it'll say that we're driving forward. If we're in the middle of a shear cycle, it'll say that the shear is going down, and then it's returning to the top. All right, so this is really nice to know where you can see what the machine is doing and compare it to what it is actually doing. So it's a good new feature that we have on our controllers. The other part of this is this run manual part. So if we were in a situation where we've used our drive and our shear function to get the machine fully loaded, and we just needed to run one part to length, we can type in our length that we want, hit run, and it's going to run one panel at whatever length you program. Comes in handy when you're in the middle of running an auto program and someone needs a different size panel than what you're currently running. You can pause, come back to this screen, type in that length that you need, and hit run that part out, and then we can go back to our program. So next we'll go to the job entry screen. And so this is where we're going to actually enter all of our different part lengths and then also run our program. So again, you're going to see our status screen across the top, so you know what the machine is actually doing, what stage it's in, or what function is happening. We also have our current position, so you can watch as it's running a panel out. You can see, okay, it stopped, that's the length, and then you can compare it to the length of your panel, which they should be the same. The next is we have add part button and edit part button. What we're going to show is how to add a part here. So we're going to hit the add part button. You get your 3 options: add part above current part, which if you had multiple parts program, but say you highlighted number 2 and you click this button, then this new part would then become number 2, and then you'd be pushed down one level. You could add part below current part. So this would add a part below the part that you have highlighted when you click on it. And then the last option is add part at the bottom of the cut list. So it's just going to go at the very bottom. So since we don't have anything programmed, we're just going to hit the top one. It's going to be default part number 1 anyway. And then this box is our section. We click on it and then we can add, we're going to call this section 1. And this section relates to if you need to section out your roof and have different numbers, so you can group different panels together, be it for shipping purposes or layout. The next box to enter is the quantity of the panels that you want to run. So here, quantity, we're going to add 6, hit enter. And then our part length, do a 6 foot part length. Once we get our part length programmed, then our last option here is stop after last part. What that means is if it is off, when we finish all of the quantity of part number 1 and we have a second part programmed, we're going to immediately go into part number 2 and start running those programs without the machine delaying. If we have stop after last part on, what's going to happen, we complete all of the quantity of part number 1, the machine's going to stop, you're going to have to come back to the controller and tell it to start part number 2. Okay, so default is always off. At this point we're going to save, and then you have section 1. Here's your completed. We have 0 of a total of 6. And so as we're running parts, this 0 will climb until we get to 6 parts completed, and then we have our length of 6 foot. So at this point, needed to add another part. I could just highlight. I can keep number 1 highlighted, add part, and I can add a part below current part. So that's going to create part number 2. There's 60. 6 foot 6 inches. Keep stop after last part it off, and then we'll click save. So now we have 2 parts programmed. All right. The other way to add a part is just on the next line down, highlight number 3, and then we can go into, we could edit part. And then this brings up the same part entry page. We add our quantity. 66 panels at 66 feet. All right, then we click save. This edit part also allows us to go up to a previous program part and allows us to edit it. Brings up all the information. Maybe I need this to be 2 inches longer. So now I can save that. Now we have a 6 foot 2 inch program. Keep programming as you need, but we're going to go ahead and run. So at this point I would I have the machine fully loaded. We've run material out past the proximity sensor. We've cut off the end of the material and we've zeroed out, and our current position will say a -1/4 inch. That is normal because every time we shear, we cut out a 1/4 inch of material. So we have to add that to each part. You don't have to compensate by adding a 6.25 foot panel to get a 6 foot. It automatically adds it on there. So just program what part length you need is what you program. At this point, we would hit run. Now we get this warning because currently I don't have my machine on. So it's stating I have no hydraulic pressure. All right. So, and here's some warnings that go through. Press start on the control panel, start the hydraulic gas motor. And we have some additional warnings to go through. So I'm going to acknowledge this. All right, so at this point we're ready to run our list. So I've highlighted panel 1 because that's the one I want to start with. So we're going to do a 6 foot 2 inch panel. I need to do 6 of them. So at this point I hit run. And we get this warning, auto run mode. It's a window that pops up to make sure that you are starting with the panel program that you want to run, and also as a warning, hey, this machine's going to go into auto mode. It's going to run panels out. It's going to cycle the shear all by itself. So if we're all set to go, then we would click run, and it's going to start running that panel out, and you can see the current position grows, and once it hits the 6 foot 2 inch, then you see the status at the top stating that it cut the panel to length. So at this point, it also shows that I've completed 1 of 6. This panel is sitting on the run out table waiting for me to pull it away so I can run a second one. And then at that point, we're running out our second part. All right. I'm gonna pull that off. Now we're running our third part out, but what I can do is I hit pause, and now the machine is gonna stop and just have, as you see, we have 4 foot 9 inches sticking out of the machine. So So at this point, we have our machine paused. We got 4 foot 9 inches sticking out. I want to continue this part. So I'm going to hit run. Hit run again, and it's going to go out and complete that part. So at this point, I'm going to not run any more panels, and we're going to show you how our different options of deleting a panel. So if you have one of your panels highlighted, you can delete current part. And so that deleted that current part and shifted everything up. All right. Or what we can do is delete all parts. Now you're going to get a warning here to make sure that is what you want to do, which it is. So I'm going to delete. So now we have nothing programmed. The other thing on this page is these arrow buttons at the bottom. The double arrow is a page. So this one would be page up, but we're already all the way at the top, so it's not going to do anything. We could go over here to the down double arrow. We hit that. It's going to page down to part number 5. So it shows 4 parts at a time, and we could just keep going down page at a time. So actually appropriate. So we have a timeout in here where the system, if nothing happens, we just get a warning to say, hey, we haven't moved the panel. You sure everything's okay? And we can just acknowledge that, and it goes back to the run page. And you'll notice at the top, we're in system idle. So back to our navigation buttons, you need to page back up to panel number 1. And then the single arrows, single arrow down, it's just going to go down 1 panel number at a time. Next, we have our coil calculator. So this is a rough estimate of if you've run a job and you have some material left on top, you can roughly estimate how much you have left. So to run through this, we're going to choose our material. We're just going to pick 24 gauge steel. So next we have our internal diameter, ID of the coil, and you can see by this drawing where you're going to measure across in one section. Typically most coils are 20 inches. Coil thickness. This is actual measurement in one spot of the thickness of the coil. So just of the material, just make sure you're not measuring the cardboard core, but you want to measure the thickness of the coil in one spot. So we're going to do, say we got 2 inches of material there, then we calculate length, and that's going to give you an estimate of 500 feet or 152 meters. All right, so this is the import-export page. We will be doing another video with a more in-depth process of how to do that, but I'll just run through it real quickly as a quick overview. So if we needed to import a cut list that we generated on a computer, instead of standing here and programming everything with the machine on, first step we would create the cut list, put it on a USB flash drive, and then we would insert that into the USB port on the controller. Then we hit the import set path, and you'll see it'll pop up the storage card, USB, whatever that card is named, and we would select that and click OK. At this point, I'm going to X out. And then once that import path is set into this box, we would click import, and then it would go through the process of reading through that Excel file and then populating the run page. All right, and then so once it imported and said it was successful, we would go back to the job entry, and then all of those panel links from the cut list would be pre-populated here. The other option is you can export a path. So say you were out on the job, you were programming, you went through and you programmed the entire job by standing at the controller, and you realized that you wanted to keep that for whichever reason, as a history of what you run, estimate a total material ran for that job, different options there. You're going to hit export set path. You would also have to save that to the storage card or USB that you've inserted into the front of the controller. You highlight that, click OK. And then once that export path is highlighted, you could give it a file name, whatever it may be, a job name, customer name, what have you. And then you hit export. And so that's going to save that program that was on the controller into an Excel file onto the USB stick. All right. And then whenever you're done exporting or importing at the end, you always want to eject your USB. Our next screen is machine setup. This is where we have a lot of the different settings. First off, you have your machine units on how you want to operate. So you can do decimal inches, decimal feet inches, fractional inches, fractional feet and inches. So we programmed already in fractional feet inches. We'll just show you, highlight decimal feet inches, and then we'll go back to the job entry scheme, highlight, edit part, and then you'll see down here you actually have decimal places for putting your inches. And we'll go back to machine setup. We'll change it back to fractional feet and inches. All right, so down at the bottom we have some more buttons here. Here we have our status screen. So this is where we're gonna help diagnose an issue while doing some troubleshooting. First thing we have on the left side are some indicators of different statuses of the machine. So hydraulic motor is indicated by a pressure switch. So when our motor is on, we create pressure in the system. That little will turn green when that motor is on. Basically, it tells the controller that the machine is on and running. Next, we have shear top of stroke. There's 2 limit switches at the top of the shear. When the shear is all the way up and those limit switches are satisfied, we'll get our green indicator here so we know that where our shear is at. Next is shear bottom of stroke. So if we cycled the shear down and it hits the bottom of stroke to tell it to go back up, this little light will turn green. And then once the shear goes back up to the top, as you can see, the light is off, but our shear top of stroke is on. So just looking at the screen, this tells me that my shear is all the way in the up position. Next is our proximity switch. This is our sensor outside of the machine to let us know if we have a panel sitting on our runout table. As you can see here, the green light is on, so I do have a panel on top. If I move that panel away, that light goes off. On the right hand of the screen, we have some data related to our encoder. So we have our encoder wheel circumference, 7.90 in this case. That's so every revolution of the encoder wheel, 7.9 inches of material is going to move forward. Next is our stopping distance. This is a measurement of when we tell the machine to stop, the material actually takes about 0.38118 inches in this machine's case for the material to stop. So this number will change as you're running throughout the day due to the machine warming up, the hydraulic oil fluid warming up. You're starting with a full coil at the beginning of the day, and then as you're working through that number changes. All right. Next is encoder length of last part. So the last part that was ran out was 73.9 inches. Just an indicator so you can go in here and tell what the last part ran was. Next is we're working on, this is going to be a length totalizer here. So it's going to give you a total length of material ran through this machine over time. So you can have it as a daily or just the lifetime of the machine. So we will be adding more maintenance, totalizers, shear totalizer. We have hydraulic on time, just as we progress with this program to add more usable data for our machine operator. All right, so our next button is machine calibration. So if we were running our machine and we weren't getting the correct length of the panels, we can come in here and do some calibration. So this first page is, before we go into calibrate, we want to check a couple things first. First, we want to check the encoder wheel for debris or damage. And what that's saying is if that encoder wheel has gotten damaged or has buildup on it, then we need to do first we need to clean it and see if it goes back to running correctly. If it doesn't and there's damage, then we need to calibrate to change that encoder circumference. So basically our encoder wheel is not the same circumference as it was before, and that's why we're getting inconsistent lengths. Next is number 2, verify encoder bracket tension. What this is basically stating is make sure that the encoder wheel is touching the material 100% of the time. If we're bouncing off of the material, then it's only going to count the length as it's touching and spinning. So typically if we have a encoder tension issue where the encoder is bouncing off of the material, our end product of our panel is always going to be long. All right. If none of these, if we've gone through all these and we still need to calibrate, then we can go through that. And so there's this little delay at the bottom, and make sure you have enough time to read through these before it goes into calibrate. So if we've checked number 1 and number 2, we're okay on those 2 things, we're still getting inconsistent lengths, then we go into the calibrate. So we have 2 options here. We can actually calibrate the machine with a tape measure of running a part, measuring it, and then entering that data. Or we can actually calibrate it by physically measuring the encoder wheel. All right, so we'll start with the tape measure. So what this is bringing up is asking us, calibration requires a part greater than 10 feet. So we're going to enter a 12-foot part. All right. At this point, what we would do is we would hit run. It's going to run this part out, what it thinks is 12 feet. And then at that point, we physically measure the part, be as accurate as you can with the tape measure. The more accurate are, the better the outcome of your calibration will be. Then we're going to enter this. Let's just say it measured 12 foot 1 inch. All right, and at that point we would calibrate with this part and hit that button. So what would happen is our new circumference, these indicators would change to a new circumference based on the information that we did. All right, I'm not going to hit enter on this because this machine is running correctly. The other options down here is that we can exit the screen just to clear out. We can also reset to default. So if we've gone through and calibrated a couple times and it doesn't seem to be functioning, we're going to reset to machine defaults, and then we would calibrate one more time, or look at other options like maybe a hydraulic issue where the valve's not turning off, look at the encoders again, things like that. Or we can just skip this altogether and we can go to the encoder calibration. All right, and this is pretty simple. We have to take the encoder wheel out of the machine, get a high quality set of calipers that are accurate, and we're going to physically measure the diameter of the encoder, and we're going to enter that information here and then calibrate with the encoder. Next, we have, back to the status, machine setup, we have our program information. This is just some information about NewTek. Also down here at the bottom, what is most important is your PLC version that you're running and your HMI version. So at this point, if you're having issues with the machine and you contact NewTek Machinery, we're going to ask for this information just so we know what version you're on, because possibly we have found a bug and you just need to have a version update, and then we would do that, send you that update, and you can just upload it and move on. And there'll be a video coming out regarding how to update your software on the new control system. Back to machine setup. At this point, you could hit exit HMI, which just closes out and takes you to the behind the scenes Windows program that the touchscreen is running, but there's really no need to do that unless we had some other issues going on. All right, so that finishes up our tutorial on the new version 2 UNIQ system. If you have any questions, contact the service department, NewTek at 303-294-0538, and follow option 2 to the service and parts, and then we'll get you in contact with the technician. And other than that, and we have information on our website as well.